Alright, hi everyone. In this video, we're going to do a simple truth table so you can see how that works live. We're going to do a truth table for this sentence here. This sentence, you would read this in English as something like, if P, then Q and P. Alright, so the first thing I'm going to do is I'm going to make a horizontal line like this. That'll be the top of, this will be the header of my table. And I'm going to draw a vertical line here. Alright. Over here, I'm going to put the sentence that I'm evaluating with this table. You want this table to be as neat as you possibly can. If you keep your table neat, everything else will be fine. Over here on the left, I'm going to put the atomic sentences that are found in the sentence that I'm looking at. So what atomic sentences do we have? We have two, P and Q. Now we know that a truth table, it has 2 to the n lines in it, or 2 to the n rows, where n is the number of atomic sentences that we're working with. Here n is 2, so we need 2 to the second, or 4 rows in our table. Now I do this the opposite way that the book does. The book fills these in right to left. The book fills them in left to right. I go right to left. You use whatever method you like, as long as it's systematic. You need to go one way or the other. You can't jump around. But I start with the rightmost column, and this column is always going to alternate true, false, true, false. So you should start with a T and end with an F. It goes TF, TF. Then I move to the next column over. This one is going to have blocks of T's and F's that are twice as big as what's here. So this one alternates every other line. Here we're going to go 2 T's and then 2 F's. Okay, so now we're done with this part of the table. Now notice I make T's and F's the same way that the book does. Some people, if they make big tables, their T's and F's start to look alike. One thing you can do if you have that problem is you can, instead of using an F, you can make an upside down T like that to indicate false. Another method is to use a 0 for false and a 1 for true. Use whatever you're comfortable with as long as you're consistent with it, and it helps you keep your table straight, okay? So now we need to move over to here, and we're going to show on what models or what rows this sentence is true and on which ones it's false. So remember, each row of this table is a way that the world might be relative to P and Q. One way that the world could be, both of these could be true. Maybe P is true and Q is false. Maybe P is false and Q is true. Maybe they're both false. Those are all different like models or ways that the world might be or might have turned out. And this helps us to systematize these models and make sure that we get them all and keep them in order. So our main connective here, remember, we want to look for the one that's under the least number of parentheses. So it's this horseshoe, it's the conditional symbol. And we want to work with the connective with the smallest scope first. So we're going to start over here and work with this and. Now, if you look at the basic truth table for and you may want to look that up in the textbook right now if you can't remember it, but and is true only where both conjuncts are true. So a conjunction is true only where both conjuncts are true. So this is going to be true only where Q and P are both true. In other words, only on the first line of the table. Everywhere else, that's going to be false. So now we need to evaluate this conditional, and this conditional goes between P and this conjunction. Now this is something else that I'm doing differently than the book. The book fills in these columns underneath each letter. I don't think that that's necessary to do. That can get really messy. when you're doing this by hand. You know, you wind up with a lot of stuff over here and it's hard to tell what's under what. It's better just to look back over here and see what the values of the different atomic letters are, right? Or atomic sentences. So here P is true, so the antecedent would be true, and the consequent is also true. A conditional is true under those circumstances. Okay, what about here? Well, here the antecedent is true because P is true, right? And the consequent is false. A conditional is false under those circumstances. So this sentence is false on this model, on this row, the truth table. Here on this third row, our antecedent is false, and I'll tell you a bit of a shortcut. Anytime the antecedent of a conditional is false, the conditional is true. So these are both going to be true. Now, because this was our main connective, and this is the one that overall gives this sentence its truth value on a certain row, we want to go ahead and circle this to show that this is the one that we need to be looking at. Or, if you prefer, you can draw an arrow above it the way that the book does. Okay? That's also perfectly acceptable.